essentially and simply put, as you, again, if this were to be a widespread thing, as you drive down the highway in a battery electric truck, you're charging the truck as you're going. That's essentially what we're looking at here, right?
You're providing the power to the propulsion system of your truck. Forget the battery for a second. We would like to just keep the state of charge of your battery. The only purpose of the battery is to get you onto this roadway, get you off this roadway. And so as you're driving, the electrified roadway is providing you the power to move your vehicle and to provide the auxiliaries to your, whatever you need within your vehicle.
So we're talking today about a project between researchers at Purdue University using a truck provided by Cummins that, and you guys are going to correct me if I'm wrong here, it basically seeks to electrify roads, giving them the ability to charge heavy trucks along the way. Before we get going with all of this, could you introduce yourselves and let us know how you're involved in this project? And Steve, we'll start with you.
I'm Steve Pekarik. I'm a professor here at Purdue in electrical and computer engineering, and I work on the electrical sides of the electrified roadway.
And John?
Yeah, Chris, I lead a team at Cummins Corporate Research and Technology, and we're looking at next generation electrification technologies for battery electric and hybrid powertrains, and this includes charging systems.
All right. We've got a lot of ground to cover here. I'm going to ask as many questions as I can to kind of guide us along here. But this project is fascinating, I think, on a number of levels for its potential and what you're trying to do here. Let's go back to the origins of this. I know it dates back several years. Who came up with this idea and what are you trying to achieve?
Well, in terms of who came up with the idea, here within Indiana, the Indiana Department of Transportation was looking at alternative technologies, looking toward the future. This was probably around 2018. And one of those technologies was dynamic wireless power transfer. And the idea there is you try to reduce the battery size and the cost of EVs and also address range anxiety. And they wanted to know, is this feasible in Indiana? What type of vehicle should be targeted? And that was an initial study that was done under what's called a JTRP, a research program with INDOT. And that led to a conclusion we should be targeting this type of technology for heavy duty vehicles, that provides a payback that's reasonable if you invest in this technology. And so that's where it got started.
And I saw the Indiana DOT kind of compare this technology to the way some of us charge our smartphones, kind of on one of those charging pads. Magnetic fields, I think, is how they kind of described it here in the simplest terms possible, so I can understand this, well. How exactly would this, or I guess, does this power transfer technology work with, again, say, a heavy battery electric truck?
Well, as you had indicated, the technology is there in terms of low power applications. So those with a cell phone, if you have a charging stand that's wireless, you're setting up magnetic fields from what we call a transmitter. It's actually time varying magnetic fields. And within your phone, there's a receiver to accept energy, that magnetic energy. Here we're doing something very similar. Within the electrified roadways, you would place electrical conductors. You would then provide energy to them that sets up time-changing magnetic fields, and your receiver underneath the vehicle sees those and takes that energy. And our goal really is to send that energy to the wheels so that you don't have to charge your battery. The electrified roadway is providing the energy to move your vehicle at the speeds that you're going. And so that's the overall paradigm that we're advocating and testing in this initial test bed.
So, I mean, again, essentially and simply put, as you, again, if this were to be a widespread thing, as you drive down the highway in a battery electric truck, you're charging the truck as you're going. That's essentially what we're looking at here, right?
You're providing the power to the propulsion system of your truck. Forget the battery for a second. We would like to just keep the state of charge of your battery. The only purpose of the battery is to get you onto this roadway, get you off this roadway. And so as you're driving, the electrified roadway is providing you the power to move your vehicle and to provide the auxiliaries to your, whatever you need within your vehicle. But the battery is in some ways bypassed. You're sending the energy beyond it so that you don't need a large battery. That's the goal.
And that would cut out so many different challenges and obstacles as we look to electrify, um, you know, heavy trucks in particular, as we're talking about here. Um, John, Cummins is involved in this. Can you talk about that involvement? And then kind of what we're talking about here, the potential of this technology is massive, right? If you could recreate this on a big scale, right?
Yeah. First, I can give you a little background on how we got involved. Cummins and Purdue are both part of what's called Aspire, and this is a consortium of several universities in the United States and a number of industry partners. And it seeks to overcome some of the challenges we see in charging commercial and passenger car electric vehicles. As through that, we learned that Purdue and NDOT were developing this project, and we thought, well, they're just down the road from us. We're located in Columbus, Indiana, maybe about 100 miles from Purdue, and we thought, we have been working on stationary wireless charging, and we saw that maybe for relatively low amount of money, we could become involved and repurpose one of those trucks for dynamic wireless power transfer. So we thought, this technology is interesting. We can get involved for not a whole lot of money. And, as you have both been talking, what are the biggest challenges in commercial vehicle electrification right now? 2 weeks ago, I was at ACT Expo out in Las Vegas conference, and it's a wonderful conference, all the new technologies, but the vehicle OEM executives were all lamenting the fact that market adoption of battery electric is just not taking off. And why is that? Well, you've pointed it out. Cost of the batteries, cost of the trucks, range of the trucks. Where's the charging infrastructure? Truckers have a trouble finding a place to just park overnight. And where are they going to charge? Are they going to charge overnight? That's going to be difficult. Are we going to have fast megawatt charging? Wired, maybe, probably, but that a lot of grid electrification. So if you look at dynamic wireless power transfer, what NDOT and Purdue are trying to do here, they can solve a lot of those problems. Smaller battery, lower cost trucks, providing the charging infrastructure or power transfer technology or infrastructure. It seems like it can really lead the industry to develop a solution that'll work for the truckers. And I think that's what we're now. It's obviously speculative. Can we do it in a cost-effective manner so that someone can afford to build it and someone can afford to pay money as they're charging or transferring power down the road? So that's kind of why we got involved. Just it's phenomenal opportunity, but there's some challenges here for sure.
Yeah, and you talk about, again, the potential, any project anywhere in the world, you got to start at square one here. This project has begun. I know construction, I think, has begun on the test bed on, was it US Highway 231 and US Highway 52 in West Lafayette. Every project goes through stages. We're in the early stages right now. Can you walk me through exactly where we are in all of this? Is it literally just now building that test road? Is that where we're at?
That's right. And John and I probably can answer on different parts of this, but the roadway construction has begun. US 231/52, just west of the Purdue campus in West Lafayette. And in this initial quarter-mile section, it's taking an existing roadway. They've been milling channels to place the transmitter coils, and that's in process. And those coils are being manufactured, and we're proud of this. Cummins is a world leader. They're an Indiana company, but there's also Indiana companies involved throughout this process. So William, Charles, and White Construction, they're doing this roadway. The milling's continuing, and in the next month or so, coils will be placed in the roadway, and then we'll be waiting on the electronics to bring to the side of the roadway that provide the energy to the coils. And then we're hoping a Cummins generator will provide us with the power to support those tests.
John, you want to jump on there?
Yeah, well, in parallel, we're working with Purdue to understand how we're going to integrate their receiver pad. So as Steve talked earlier, there's transmitters, coils in the roadway, and then there's a receiver pad on the truck. And that receiver pad is designed by Purdue. And then there's power electronics, which convert the AC power that's being transferred to DC, that the vehicle, either the batteries or the powertrain or the accessories can then use. So we're working right now with the Purdue researchers and integrating their components onto our truck. We're doing the design. There's obviously controls when you add this. How do you communicate between the two? The truck, at times may want 100 kilowatts of power transfer, and sometimes may want the maximum, which may be in excess of 200 kilowatts. So we're working through these details. And then near the end of this year, early next year, we'll physically do that integration on one of our battery electric demo trucks. And then about a year from now, you can show up in West Lafayette and see this testing in action.
This is a heavy lift, I think it's safe to say, because we talk about the potential here, but there are a lot of moving parts and a lot of things that kind of have to go right for this to come to its full vision here. You talk about some of the challenges there and the unknowns, John. I'm curious from both of you, what are your biggest question marks, your biggest unknowns, your biggest challenges right now as we look toward this? Because it sounds like a great idea, but obviously putting that into motion is going to be, a difficult task. What kinds of things are maybe keeping you up at night, or maybe making you think, how are we going to get around this challenge right now?
Yeah, I mean, personally, I think we'll get the technology down. I think the project will be successful from a technology standpoint. I worry about the cost. Can we truly get the cost? And can we have financing partners that understand the payback for this is in the 10, 15 year, 20-year time frame? But this technology will work. It, in some manner, it will be rolled out commercially in certainly limited areas to obtain wide scale electrification, which may be 20% of the interstates, let's say, and you can have a battery to go in between. I think that's something I'm unsure. That's my worry. I think it has great potential, but can we get the cost down? Go ahead, Steve. I'm sure you've given this some thought too.
No, I mean, you've hit it. The part of that cost, of course, is providing the connections, the power to the roadway, right? So you have to supply the utility or this new entity we're calling a public-private partnership, at least to start, which we'll call an electrified roadway. They have to get power from a utility and then put it to the roadway. They have to bill and all of those type of details. The billing part, I'm sure they want to make money. That's not the issue. The issue is, where do you get the power from associated with this? Let's say it's 10 megawatt levels of power every mile. Okay, where are you going to get that from, especially in a power desert? Maybe this is between Indianapolis and Columbus, Ohio, on a major trucking roadway. Okay, what happens midway through there where you don't have large amounts of power? How do you get that there? That's going to be the big part of this, is that rollout. I think that's the big hurdle.
Yeah, we have hard enough time rolling out EV charging infrastructure in discrete locations.
Mm-hmm.
If we make it more continuous locations like this, I mean, maybe in some ways it makes it easier, in some ways it makes it harder, but can we make it cost effective?
Right.
We can't have truckers pay $1 a kilowatt hour for energy.
Right.
Yeah, that makes sense. I want to ask you two different scenarios here, and we'll start with the first one. And you've kind of laid this out, but I want to make it clear for everybody out there about what this would look like if this project is successful on every metric, if everything goes according to plan and your vision of what you think could happen actually does happen. What does this look like for, again, your average everyday truck driver out there who, maybe has a battery electric truck? We're not just talking Indiana here, we're talking nationwide. What does it look like? Is it segments of the interstate here and there, and they are charging, at different stations, wherever they may be? Kind of lay that out for me if you could.
John, do you want to take that first, or do you want me to?
Go ahead, Steve. I'll let you go first if you want.
Yeah. Well, I think John alluded to initially that it would likely be on select dedicated roadway sections, and our initial vision looking long term is this is consecutive over large swaths of the interstate system. That's not anytime soon. So my speculation is this would be placed on main thoroughfares, 100-mile sections, and dedicated vehicle over those sections consistently. As the technology matures, then it moves out from there, and you have larger swaths of the interstate system dedicated to this, and that may be 25 or 30 years from now. I'll let John edit that comment and maybe provide more feedback on that.
Yeah, I agree with you, Steve. It'll roll out in regions, maybe obviously heavy transportation regions. There'll still be overnight depot level charging. If you look at there are dedicated identified electric vehicle corridors that the federal government has said these are the corridors, and you just look at where truck traffic is predominant, and you can go after those. And some people, if we build it, some people will start using it and some people won't. And if those that start using it start to gain a competitive advantage because they don't have trouble finding charging stations, they're building the trucks, they're buying trucks with smaller batteries. And it'll if it works, fleets are pretty smart. They'll gravitate to those solutions that work. Now, again, it's going to start off in regional haul, but But pretty soon, you'll have regional haul trucks that maybe aren't stopping for overnight charging, or they're able to easily run the, slip seat where they don't have to stop and, charge overnight. So I think if, it's one of those, if we build it, they will come. I think that'll happen. But again, it'll happen, like Steve alluded to, in limited regions, and then it'll start to build out. But it's up to us to make sure that can be done cost effectively.
So that's a scenario where, again, everything works out as planned. Let's say it doesn't. Let's say things don't quite pan out the way you think they might. And I think of the NASA space program and all the inventions and technology that came out of their work, from, computers and medical equipment to everything else that we know about. Even if you swing and you miss on this, I imagine you are still going to learn something valuable along the way. Have you thought about some of those, ancillary extra things that may come out of this? Again, if this major, if the big project at large doesn't pan out?
One of the projects we're working on outside of this project, but one of the projects we're working with Purdue and Oak Ridge National Labs is a new stationary wireless charging project, 750 kilowatt stationary wireless charging. And I think those are easier to build because they're in discrete locations, and high power wireless, where a trucker doesn't have to get out of the truck. Maybe we can install those at loading docks where you don't have to worry about cable management. I think some of those same technologies being developed for dynamic are transferable to stationary and vice versa. So I think stationary is a great way to start. And then, if dynamic works, it can be the same technology that is sometimes used maybe at higher power levels when you're stopped, and then at these other power levels. So I think, and just, our increased working with Purdue and other universities and the Aspire Consortium, I think is helpful to us. But go ahead, Steve. I'm sure you have similar things.
Yes, I mean, our goal is ubiquitous charging to bring down the cost of EVs and address range anxiety. So this continues to address that. All of the technologies we're attempting here, as John had indicated, translate over the electrical designs. How do you provide power to these systems? This is all helpful toward those goals. You also have the potential for niche applications, for example, in ports or inland ports where you have these dedicated routes. All of these technologies can be directly leveraged there without the huge infrastructure costs that you have to work through the details of that. And there's not a overall political process, not to the levels of, things will change every 4 years, that you have to overcome different administrations having different desires. Those will likely play out. And then if you look at DoD, Department of Defense, they have numerous things where they're doing electrified applications, continually upgrading their electrified ships and looking at technologies like wireless. How do you do that in particular port settings there to enable you to do, better, faster responses? Finally, if we look, and this may not be in my lifetime, I don't know, but people are looking at electrified aircraft and saying, okay, let's transition this type of space. This directly applies. The electronics we're applying here, the technologies that we're developing can be leveraged therein as well. So yeah, I think this sets up a whole potential for the next generation of engineers, kind of like the moonshot did. That we didn't colonize the moon, not to date at least, but that moonshot provided financial and technology incentives that we're still benefiting from. And this is one of those type of things I think we're still doing here are opening up those channels here.
Yeah, again, which I think is why this project in particular is so fascinating, because it speaks to a larger issue. We talk about the lack of charging infrastructure, and what this speaks to, and what both of you have said, and I think we all know this, it's going to be a patchwork of things when we finally get to whatever this is going to look like here. And it is coming, whether you like it or you don't like it. And all the conversations are being had now. So it's interesting. We're at an interesting point in time, I think, in that we know where we're headed. We just don't quite know how we're going to get there. And that scares a lot of people right now. And I know you both probably understand that, professional truck drivers in particular. We talked about all the challenges out there with all of this. They just want to work. They just want to do their job. But again, something like this would make that easier as we get to an electric vehicle era, or whatever we want to call it, right? I'm sure you've heard those fears, especially you, John. I'm sure you've talked to people who have expressed that to you.
Sure. Yeah. Some in the industry use the term for the next 15, 20 years, the messy middle on what our powertrains and what our trucks are going to be powered by. Is it going to be hydrogen? Is it going to be fuel cell? Is it going to be natural gas? Is it going to continue to be diesel? Are hybrids? And, Cummins is looking at all of that, because we know, again, over the next 15, 20 years, there has to be a wide variety of solutions. And then we'll see what can work cost effectively. And if we're successful at projects like this, well, then battery electric will be a lot more usable, productive, cost effective to the truckers. We can't have the truckers have to try to find a charging station, and now they're running low, and now they have to wait. I mean, again, you can you can think of the challenges to electrified trucking. We need to make it easy. Part of the problem is diesel is so incredible. People don't realize the phenomenal energy density, and we're trying to create solutions that compete against this, because trucking fleets and truckers don't want to change their operational model, and nor should they radically. Small operational changes maybe, but so how are we going to compete against that with the new technologies? And this dynamic wireless power transfer could be a way.
Steve, do you want to add anything there?
John said it brilliantly.
Yeah. As we kind of close things out here, is there anything else either of you or both of you want to add here? Maybe a question I forgot to ask, something you think our listeners would be interested by? Anything along those lines?
I think a question we get when we talk to truckers, and again, we have talked to them for our stationary wireless charging projects, is the safety aspect. Is it safe in the truck to have these magnetic fields? And it is, because one of the design goals is you ensure that magnetic field meets safety standards. And there's different ways of doing that through the electrical design and through shielding. And so our stationary wireless and our dynamic wireless are safe in the truck. And then if a truck isn't over the pad at that time, and you're just in a passenger car running on this, the coils are not electrified. They're not energized, let's say. So I think a lot of work has been done, will be done, to ensure the safety.